what exactly is inside the string view in C++. If you don't know, in C++ 17 they introduced a string view, which is a lightweight non-owning view into an existing character sequence. Now today I'm going to rewrite string view. Let me just show. I'm going to rewrite string view in C++, and actually I'm going to show you how string view works. So first we have this string view, and then I made a print sv function. I created a string s here, then I print it out. So string s, this is not a field string, this is a string, a C++ native string. I have a string view here, and I'm converting the string s into a string view. This is an implicit conversion. Yeah, implicit conversion, if I was not wrong. Yeah, this is an implicit conversion. So if I run this, which is gonna be G++, then I'm gonna compile it, I'm gonna run it. I got this. Buzz, 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 buzz. By the way, let me just not do that. So that works. Now let's go rewrite string view. Let's make StrView.cpp. So let's go rewrite string view. Now the first thing I want to have in my string view is the string view class. Let's do, oh actually, what do I have it in CPP? I just want to remove that. And let's just remove that to StrView.cpp. Did I call it right? Yeah. Server.cpp to StrView.h. Huh. That's weird. Hold on, that's weird. Oh, I just deleted. Since when did I delete you? Alright, whatever. Let's just make a new StrView. Let's call it StrView.h here. And let's go do pragma once. And here I want to declare stuff. Let's go define what is a string view. A string view is basically, let's go to class. It will be a class. Let's go call it string view. And this class, we need to define the constructor. So what exactly is inside a string view is that it has a const char pointer, which is a constant string in C, and it has the length. So string view, it will view a string by pointing towards that string or pointing towards a part of that string. So it can view a part of the string or an entire string variable. That's one. Now let's go and let's make a let's go make a private. First will be inside the string view. So we need an const char pointer. By the way, I like this. I'm gonna call it data. Should I call it data or string? Nope. It's going to point. It's a point. So it's called m pointer, because if I call it data, that will be inside structure inside C. I'm using a class here, and it's a private stuff, and it can only be read by the string view class, not other way. So we're gonna make that happen, and then let's go stud size t mlen. Let's call it mlen, you know. Oh, and I bet size t is not included. Alrighty, so stud size t. Where are you from? Stud size t. It's an unsigned integer type in C++ that is used to represent. Yeah. So where is the library? Oh. You should include the C standard definition. Okay, so I'm gonna put it in the C standard define. It's gonna be include C standard def. What is it called? F though. Steady def. Stud def. Yeah. That's wrong. Stud def. Yeah. C standard definitions. So I have a size T now. All right. That's the bones. That's the structures. Now let's look at in the public stuff. So constructors. We're gonna make constructors. All right. We're gonna make a constructor. So this constructor will be in public. If I believe what the fuck will be in public. And let's go have some cons expression. And then gonna be the name string view. That I will take nothing. First, yeah, nothing. No except. How do I write no except? Hello? Where is my linter? Where is my actual linter? Oh, I'm not in C++. I'm in a header file. No. Not accept that. All right, and then I will do. Oh yeah, I will set everything to a null pointer first. But wait, let me look at it. Yeah, I'll just make it like this. So m pointer will be what the fuck? M pointer will be a null pointer. And then m length will be 0. Is that it? Let's put this. Yeah, that's everything. Okay, that's our first empty constructor. This is an empty constructor. This is going to be our empty constructor. Then let's go make a constructor from pointer plus explicit length. So again, const expression. Why do we use const expression, if you ask? Because it's faster. It'll be done in the compile time. We don't want anything to be done in the runtime. We want everything to be done in the compile time. That's how StrView works, I guess. So okay, this requires us to have a const pointer. This will be our pointer and what the fuck, pointer comma, and let's have a size t len. Size t len. That'll be it, right? Yeah. And then no except. Okay, writing has become a pain in the ass. Oh, actually no, there's no need for that, but okay, I'll just keep it like this. So then I'm gonna do is a m pointer will catch the pointer. Hello, pointer. And then m.len will be the length. No, I don't want 0, I want to be length. Yeah, that's everything. Okay, alright. This could go down there. Yeah, that can go down there. And I will just put that, please. Yeah, I'm fine with that. Okay, that's from a pointer with an evaluated size. Explicit length, I mean. Now from a null terminated C string. This is quite a long stuff to deal with. So we're gonna do it is from a null terminated C string, which will be the const job pointer. This will get the C star. Then I want to this. I want to m pointer will be the C star. What the C string? That's C string and comma. The length is, holy cow. Okay, the length will be something nasty. So I'm using built-ins, right? The document I'm reading a documentation behind. If you guys don't know what I'm doing, I'm reading a documentation behind the screen, and this is a disaster built in. The documentation is definitely not Claude AI, because Claude is so good. Holy cow. C string 0. So if it's a C string, I'm gonna build in strlen C string. If it's not, it'll be 0. That's simple, right? That's actually very simple. So the length, I will check whether it's a C string or not. If it's a C string, I will check the length of the C string. If it's not, I will do 0. And by the way, why does it seems to be weird. I don't trust my NeoVim this much. I hope my NeoVim doesn't break. But it's a header file. Okay, it's a header file. And wait, do I use? Let's just Google up. Do I use header files in C++? Do I use header files? Yes, you actually use header files in C++. Mentions contain the collections of the types. I could use HPP because that'll be the best to use. Let me just mv this StrView.h to StrView.hpp. That way, I don't get arrested by stuff. Alright, I still have multiple stuff there. Alright, let me just ask how to compile C++ with a header file. Okay, there's ifdef, infdef, or pragma ones. That's what I'm using. I'm going to define all the constructor here because I think it's, yeah, I'm going to define all the constructor there. It's a constructor. There's no real definition of each functions. It's a constructor, so that'll be the constructor. Alright, that's that. Oh, so if I try to, oh yeah, I get it. Okay, I get it. So okay, let's go back here. So we have a null terminated string. This is a null terminated string. Then let's check if we have a, oh by the way, I forgot the no except. For real, almost got me killed. No except, please. Alright, thank you. What the fuck, dude? Get the hell out, man. Okay, then let's just do, okay. From standard string, borrow its internal buffer. Alright, let me just check. Standard string reference next. Oh, okay. Yeah. So it'll be just the string view. I will take a cons of a standard string, then I will borrow. By the way, if I do that, let's do s. I love the reference and pointer expressions before next to the my variable name, whatever. Okay, then I'm gonna no except. Alright, that will do what the, oh crap, mother hell. Sorry, didn't do it, why not? Oh, I should have not. Okay. Bleh. Sorry. And this will take the m pointer with the s.data. Right, and we'll take the len, I believe, with the s.len size. C++, why do you have it as size, not length? Seriously, man, be different. C++, be different. Alright, that's done. That's our constructors. Now let's implement element accesses. Oh hell no. Element access, guys. Got a lot of element access. Yeah, let's go implement element access. So here let me just do new public. Now why do I make a new public? I want to separate which one is for, wait, can I actually do have two publics? Can I have two publics? Two publics. Hello? Publics in oh yeah, I can have multiple public and private. Cool. So I'm gonna have two publics here. I'm going to make my element access. This is gonna be our element access. Alright, it's gonna be our element access. element access. It's gonna be our constructors. So constructors stay here. Constructors, stores like it's stores, not tourists. I'm not oh yeah, constructors. So okay, I'm gonna make a constructor. It's gonna be our indexing or element access. Oh, what the hell, dude? It's gonna be our element access. So what will we do? First, I'm gonna do a cons expression, which, by the way, I think cons expression is supposed to be included at some point, but okay. Operator, that operator, this will take some std size t, yeah, size ti. Then on the cons expression, cons no accept, I mean, no accept. What I'll do, I'm going to return m pointer I. So this allows me to let me just edit no, I'm just gonna edit main.cpp. So let me just include my stuff here. Well, I'll just include later. So I could access string views just like how I access string using something like let's make my own string view here. Oh, the string view sv. Let's do that. I'm gonna do from the s. Yeah, that to our string view. Is that how it works? I don't know. How do I assign string views though? Let me just check. How do I assign for string views? Yeah, whatever. It has that. So I could theoretically I could access the, since string in C in C++ is just an array of characters, I could theoretically access them by this table symbol or the array symbol here. So I could access it like that. Theoretically I could do that, but yeah, well, let's just see. Let me just do things back and forth again, and then that's done. Okay, that's done. Now let's look again at, there is at, no bounce check. Okay, no bounce check. Oh yeah, there's no bounce check here, so I don't know what bounce check are. I don't know, who cares. Then there's at. Okay, this is simple. This is just going to take a cons expression. So then I will just char at. This will take our standard size. What the hell, man? Size ti, not ui, sorry. And I'm gonna const it. Alright, that's fine. So if I is more or equal, yeah, more or equal the m length, I'm gonna throw. Oh, there's a throw. Oh, this is gonna be set except, yeah. Yeah. Std out of range. Now where the hell is that? Does it come from? String view. Yeah. Then I want to return m pointer I. I have feelings that I need to include every single thing. I need to include every single thing here. So first I have a C standard definition, then I probably need something like accept. So to get std accept, you know, Cons expression. Let me just ask all the libraries it uses. Let me just yep, there's std accept, string, algorithm, and string view. Okay, so there is just include std accept, which is what I'm using right now. I'm also going to use string. Yeah, I have a string constructor. Do I have that somewhere? Oh yeah, I do have that. So I have std accept, then I need the std string. First gonna be stack include string. I have std accept, I have string, and string view. Oh, that's why. Like, well, let me just put this thing right here. Include string and include string view. Oh, not there actually. There's no need for that. Yeah. Okay. So that's all. Okay. Alright. Okay, so I'm back to element access. Okay, back to element access, people. So we have this string view at. So it's gonna be our string view at here. We'll go through there. Then what else am I going to do? Let's do something nice. I don't want to do actions. I don't like underliners. So there's the front and there's the back. Alright, so what we could do is like const expression char front. Why do you always put 0 there? I didn't do that, okay? There's gonna be a const no accept return m pointer 0. Okay, I love my pen. Correct. So okay, so we're accessing from the front, then we're going to access from the back. It's gonna be char back const no accept return m pointer length minus 1. That's the logic, right? Yes. So okay, we have front and back now. Why do we access from the back like this? Why don't we just mlen? It's to avoid buffer overflow. So we are accessing a memory that is not there. We don't want that, okay? Alright, and then we have char pointer data. Const char pointer data. This will take nothing, and then const no accept. And then we're gonna return return m pointer. Yeah, good. That's element access. Oh, good. Yeah, I'm doing great. I'm doing very great. All right, that's supposed to be nice. Now let's go make a public again. Let's go make public this, public that, public should be. What the hell, man? So we have this. It's gonna have capacity and iteration. All right. Capacity and iteration. I'm gonna put this on GitHub if you want to, but I will not. So okay, our capacity and iteration logic should stay here. Why is my mouse there? So let's go make const expression, and let's do stud size underscore t size. Oh wait, I don't want size. I want. Should I use size or length? Both are the same thing, and I don't know if I should use both. size or length? Hold on. What should I use though? Let me just read some WhatsApp messages, guys. Hold on. Hold on. Yeah. Let me just read some WhatsApp messages, guys. Hold on. Yep. Who cares? So, what should I use? Should I use size or should I use length? The documentation say I could have both. I'm thinking I'll go with both. Should I go with both? I'll go with both, I guess. I prefer length though, because length is the best way to capture everything, you know. Whatever, just call it size. Just use size, people. Who cares? Cons. No accept. And then let's go return mlen. Return mlen. So we're also going to do the same for. By the way, let me just add a tab there. Const expression stat size underscore t length. This is the answer length. We have cons. Oh, where's the tab? Good. No accept. It will also return m_len. So we have two same functions here. One is named size, one is named length. There's no difference. They're returning the same value, m_len. So which one do I prefer? I prefer length over than size. And I could put two, but some might actually love to have size more, I guess. Some, not me. I love length. Length matter, people. Size has its own radius, you know. So yeah. Okay, whatever. Let's just let what the fuck? What the hell? Okay, let's just continue with this. Let's let it slide, and let's go const expression ball or bool. Let's go expression bool. Oh, by the way, is bool a type C++? Let me just bool C++. Do I have bool in C++? Do I have bool in C++? It's pinned. Oh, it's not. Do I have to include a library? So I have to include a library to use a bool in C++. I mean, in C you have to do that, which is the cool. Bool is not needed to be included. Oh my god, I had to include the standard library for bool. Just done my thing. So I have standard bool. Let's just call it empty. Now this will return whether it's empty or not. So const no accept return m and 0. Okay, so we have that, we have this, we have that. Funny thing, I guess. But only go. Who cares, man? Let's just put this empty here. Much more readable. Yeah, way more readable than before. Yep, I love it. Then we have a const char begin and char end. So oh my god, we have the same stuff. C begin and C end are the same. View is always const. Oh yeah. So const expression const again. Okay, char pointer begin, which will take a const no accept Then let's do return and pointer. Alright. Then we have a cons pointer, cons child pointer n, which is gonna be cons accept. Let me just do this, cons no accept, which will return m pointer plus m length. Okay, return m pointer plus m length. We have that. Okay, we have that. Just zoom it out for you guys, for you guys to be able to see it. This is much clearer. This is already too clear actually. Why is my scroll so fast, man? I hate using my mouse for everything. Alright, so we have a capacity and iteration. What if I test it right now? Yeah, what if I test it, you know? What if I actually test it, guys? What will happen if I test it? So, let's go include. Let me just remove these people. Delete you. Delete it. Let's go hashtag include my strings. Let's go my string view.hpp, and this is going to be the standard. No, it's going to be the string view as v. I have the length of the end line. Yep. And let's do this. Let's do this. Let's see what can we do. So how do I put the command though? How to have command to open the command in new view. There's a term. Oh yeah. I could use a term command, which is as easy as doing term. Oh nice. All right. So in the term, let's do. What do we do? Let's. Where are we? Yeah. Ls again. Let me just see. G++. Alright, we have so many errors. Oh, I haven't. Oh yeah, I haven't. Yes. That makes sense. I haven't done that. So if I want to print it out, or what do I expect after class? Oh wait, really? Oh. So if I want to print it out, I have to, you know, let's not print it out. Let's just declare it. You know, let's command this stuff. You know, let's put a command on you. You know, just command you all, and I'm gonna command you to. Let's make my own SV here. Let's go call it string view underscore SV. It's gonna be an unused variable. Oh, why did I close it? I did not close every single thing. God damn it, man! Should have done that, but okay. Let's just do return. And if I ing G++. Oh yeah, forgot that I have to do that. So in here I forgot to put a. Sorry, my dumb ass. Sorry guys, I didn't do it. It wasn't me, I swear. Okay, that compiles. Main has nothing. So what happened, Ian? What happened is that I haven't implemented the bitwise operator, and I have to do it. You know, so in order to the standard cout to work, is to use the bitwise left operator. I haven't implemented both bitwise left and bitwise right. I'm going to do it in a second. Just believe me, I'm going to do it in a second. So let's go back to the documentation. Now we have modifiers. Ooh, this is what I like. Modifiers, I love modifiers. By the way, this looks so dumb. It's okay. So now we have modifiers. Let's go public and let's call it modifiers. Right, modifiers. And yes, we don't have any allocation. Nope, nope, no, 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 man, what the hell, You're so annoying. So, okay, modifiers, what do we have? We have a const expression void remove prefix. This will take a stat size, that's not a column, size t n, sorry, with a no except, it's just a const. And okay, m pointer will be plus equal n, m length will minus equal n. Okay, m length minus equal n. Let me just go through. I will speak after I'm doing everything. Const expression void remove suffix. What's a suffix and what's a prefix? I'm suffering in a suffocating world. I am suffering in a suffering world. Who cares? So I'm gonna return. Oh, what the hell? I'm not returning. Oh, what? Return. Sorry, man. And so, as you can see here, I'm not using any allocations. No allocations. Literally no allocations. I'm just setting the m pointer to plus equal to n, so that I'm setting the string to have more string into it. And if you ask me, how could that work, Ian? Well, since const char pointer is a pointer, and pointer is basically just an integer pointing towards a value, which is a char here. That's why we have string, because we have integers putting everywhere. So when I say size t, that's also a thing. We are putting a new integers, a new size into that string, so that string doesn't. So how do I say this? Yeah, when I say remove prefix, I'm taking from that n. From that n, I will add a new, new string for the n. Then I want to decrease the length, so that instead of, how do I say this? Yeah, when I remove a length, I can't just remove something from a constant pointer. That will break that char pointer, that string. I need to add new stuff to that string first before I decrease the length. You get the idea, man. You get the idea. Whatever. And there's an allocation too, so that's cool. I guess that's cool. So just public. What's gonna be our searching and slicing? Oh wow. Woo. Oh. Yep. Oh, this is where I should use study min. So let's just do a const expression stud size d substring. Let me just call this searching and slicing. Okay, size d what? Size d subster. Okay, subster. This will take a size t position, comma standard size d count equal to nan post. Huh? What's an nan post? What the hell is an end post? What is C++ endpost? C++ endpost. What's an endpost? It's a special static constant used to indicate new position. The most common use case. Oh, it's a static constant. Let me just ask, is endpost? Let me just ask, is the endpost you are using string endpost? Let me just ask. Constants, okay. I don't have any endpost though. Which only, okay, both are defined as which only 64-bit machine system is the maximum length. Yes, since a valid index can never reach this value, it serves as a sentinel, meaning not found until the end. Belongs to. Oh, so we are making our own endpost, which I missed somehow. Where's endpost? How did I miss endpost? Yeah, so we're gonna make an endpost. I think it's a private thing too. So endpost will be our private, right? Can't compare with them with. Is this a private object? Static constant expression. All right, it's not a. Oh, it's a public endpost. So you can refer to it as that. It's Yeah, I get it. All right, I get it. Okay. So there, I forgot about end position somehow. Where should I put it? Should I put it here with these? It's firstly used in these side low, so I'm gonna put it. So I got static const. Okay, what's it in? Static const expression size, standard size t and pose equal to standard size t. My god, holy cow. -1. Alright, it's end position. Well, let's continue programming. Let's continue coding. Okay, we have that. So we have substring there. So we have count and post. So that's what I was missing here. Where did I put you? Where did I put you here, man? Come on. Be not ridiculous. You should. Hello. Okay, thank you. Thank Lord. So okay, we have endpost there, and then we should have a const, no except, okay, const what? And if pos is more than m length, then I want to throw std, was it xd out of range, let's call it substr. All right. But wait, do we call it substir? Just that? I'll just call it std stir view like that. Yeah, what is just called like that? Who knows? Who cares? Okay, that's done. And then let's go do is the standard size. Then we're going to actual, and it's going to be and standard minimal. Okay, standard min. Just going to do the algorithm, which we're going to use algorithm count and length minus post. So okay, we're going to use the standard algorithm, which is include algorithm. What is include do? There's no include do, there's only include. Algorithm. Cool. Nice. And then set to there, and I'm going to return. Oh. So I'm going to return the string view. Let's take the m pointer. It's not okay. M pointer plus position comma actual. All right, this feels like a macro for some reason, but it's not macro. See, it's just that good. So I am guessing we are using this construct pointer. Yeah, we're using the second constructor that takes like that. Okay, a pointer and a size t len, I believe. Yeah, I guess that's what we're using right now. Alright, good. So let's do cons expression and then do std size. Oh, this is not a size t, this is supposed to be a string view. That's why. Oh, my bad. String view. This is my bad, people, my bad. Sorry guys. That should be a string view. No. Did I make it from here? No. Oh man, I hate custom types. They're not like C. What is wrong with C++, bro? Delete to the LSP. I don't know what LSP I use though. They're not doing the great thing. Alright, let's go to size t now. Const expression. Start size t fine. You should go with chassis, comma standard size t plus will be 0. So we have a default value in C++, which is cool. I hope they have it in C, but C is old. No except. And it's fine, that's okay. We have void pointers. There's no need for template type name T. We have void pointers. Just put pointers there, pointers here, and everything will be fine. It's a nightmare though. Void will return null. If you pass null, you will die. Man. I hope I didn't do anything wrong. Alright, good. So if we have that char C start standard position. So okay, in this function I want to iterate how many times? That many times. So for the standard size ti is equal to 0, no. It's equal to pause. So pause, comma I is less than or more than mlan, yeah, less than mlan. And I'm gonna plus. Oh, by the way, what the hell did I use, man? I just used comma in for loops. What the fuck? Plus I. Now I don't know why to use plus I though. What's the difference between plus I and I plus plus? I don't know. So I'm gonna make an if m pointer I. That's O, dude. That's not I is equal to C, then I want to return 1. Return 1. I just misread it. It's gonna be I, and then return and position because it'll be null. Bye bye. Number and position, people. Cool. So then we have start with and so we have subster for subview with no allocation. Okay, we have subview. Yes. I know. Start with. Okay, start with. Why do we need to start with? I don't know. Const expression. A bool which have starts with. So we take a string view prefix. Alright, so I'm gonna make string view prefix. This is how you name class. If you don't do it like this, you're cooked. String view prefix. Then const no except. What did I do? Return mlen is a more equal prefix dot m_len. Wait, can I access that? I don't know. Probably I can, but wait, can I actually access that? Huh, that's weird. Hopefully I can't, but okay. Alright, whatever. And okay, and what? Standard char traits. That's from the string, right? Yeah, char traits. Char compare to m pointer, comma prefix dot m pointer, comma prefix dot m length is equal to 0. Okay, that's, we could do that, I guess. I don't want to X. Oh wait. Oh, so we're comparing the current. So we're compiling the caller's m pointer and the prefix m pointer and giving the prefix length. So we're starting with that prefix, you know. I know what this is. Yes. So we're starting. So we are going to check whether this string view is started with a prefix, with a string. For example, if I have a let's say we have a sukabliat. What the that's a string view csv. Gonna make hello, you know. Hello. Oh, by the way, we don't have equal, so yeah, there get it. There's nothing for equal, I guess. And so if we have this, we have a string view hello world. If we use the underscore sv dot starts with, it's gonna be hello, and yeah, this actually work. So I'm gonna check whether sv starts with a prefix hello. Here we have hello, so hello will be our prefix, and we're just going to check whether it starts with that or not. How it does that, it's going to use this string char traits char compare. So we're going to compare the sv m pointer with the prefix m pointer by the size of the prefix. So that's how we're going to do it. It's very logical. It makes sense. You know, everyone could handle that type of thought. Man, who cares? Okay, let's start with now gonna be end with bro const expression. Let's do boolean and going to ends with because we are English. String view suffix cons no except. Oh, oh man, lovely, lovely people, lovely. Return m underscore length suffix dot m underscore len. Alright, and so we're gonna start doing the same thing again. Am I right or am I wrong? I'm doing the same thing again. Yeah, I'm doing the same thing again. Okay, char traits, char compare. This compare is quite different somehow. So m underscore pointer plus m underscore len y m underscore len minus suffix dot m underscore length. That's lam, Ian. That's not len. Lem. Okay. And then suffix. Gonna take the m underscore pointer, comma, the suffix m underscore. What the fuck? What the hell, man? Oh, come on. Seriously, man, you're doing me that? You're ugly, bro. Oh, by the way, this could go here, I guess. It's not that long. People could read this. I forgot the equal to 0. Haha, that's a problem. Which probably be true. Yeah, I can't think like that. This looks so. This looks so dumb and so fascinating. It's not. Oh, there's that. There's that actually. Oh, that's where I messed things up. I didn't miss things. I didn't miss anything. I was just trolling, guys. I was just trolling. Alright. Well, what time is it? 14:44. There's still more time before the answer. Right, that's done. Now, let's make it now public. Then let's have comparisons. My love. Comparisons. Let's do comparisons. Comparisons. No. Oh, come on, seriously, man. What the hell? Const expression. Go make an int compare. I'm gonna take a string view other. Oh, this. So I have to put const no except size t minimal length. This is going to be equal to standard min. And then I'm going to mlen. I'm going to scroll len other dot len. Yeah. That's done there. I'm going to int result. I'm going to have a standard char traits. So we'll have a char, then compare to m pointer, comma other dot m or pointer, comma other dot m underscore len. Okay, that's done that. So if I do if result is not equal to 0, I want to return -1. Oh, I want to return result. Sorry. And if it's else if, but now actually it's if if mlen is under the other is less than other dot m_len, return -1. If m_length is more than other dot m_len, I want to return 1. Okay, let me just scroll down a bit so I can see clearly. And I'm going to return 0. That's cool. Now then, const expression. Just make it here. It's better. Const expression bool operator. I don't like how they name operators like this, man. It's like this, you know. It could have it like this. They could make more spaces so that I could see better. Where is it? Where is it? Where is it? Where is it? Yeah, here. Put more spaces so that I could see it better, man. I just hate it when they mix the operator keyword with the actual operator. That's just a little, you know, not great at all. StrView O. Why do you name it O, dude? Name it other, man. It's const. No, except return length bounty other dot length compare other so we have compare. Nice, we have compare. So that's how we do it. So this is equal operator. We'll check whether it's that or is that. And we have the same things over and over again, and they're just using the O. Use a readable name. Use a readable name, seriously. I just learned that the people that read your code is just not you. People who read your code is everyone else who's gonna read your code, so make sure your code is that readable. It's good code. Having an unreadable code will makes an unreadable person. It's not their fault when they don't recognize you. It's your fault for not being recognizable. Perhaps it's your fault for trying to be niche when things should just go as is, but you tried to become someone better outside from this world. And honestly, I'm trying to avoid that. I'm trying to, you know, oh fuck. Let's use step. Oh. I'm trying to, you know, make myself readable so people can understand, but it's not easy, you know, making people understand what you're trying to do, what you're trying to say. Sometimes you have to make your own cuts, sometimes you have to train yourself. Eventually, when you fail, that's your fault somehow. But I get it, that'll be always your fault. You can never blame anyone besides you, because you're the only one who lives your life. But there are other people, yeah, there are other people. They are living their own life, you know. They don't care about you. They much like as you don't care about them. They can move on. They know how to move on. hurts. It hurts to know, I know. Reality of life is not that easy. Always make sure that you are writing something readable for people to understand you. If you want to be understood, make yourself understandable. Don't ask for people to understand when you can't even understand yourself. Perhaps that's your problem. You are hard to understand because you can't understand yourself. You just want more time to understand yourself. You need that. More time to understand yourself. Okay, that's done. Right. How are we supposed to print this? How are we supposed to print this? Alright, how are we supposed to print this? I need the operation, right, for the bitwise operation. I think I need that. Let's go ask. Alright. How are we supposed to print it? You know, it's an on and null time string. You can't just press it to print after all of the arguments. There are two ways. The classic ways, which is the C style way, is to use how do I call this? Oh, I could assign that. So the C style way is to use the printf pointer s dot pointer s per n. I have seen that way before in Soding's video, one of his video. I won't use that. That's not really recommended. It's quite bad. Oh, there's std format. We support string view as a format argument. Ooh. I'm gonna use the std, you know, the classic os.write stuff. Okay. So that will be, wait, let me just check. OS stream. C++ OS stream. It's located from, we typically include IOStream, so yeah, I'm going to use IOStream, which automatically includes OSstream. Actually, I'm just going to include OSstream because I don't think I'm going to have OStream. No, let's use IOStream too. IOStream, you know. And let's have here, let's make it public. Let's call it IOStream. Alright, go make a const expression. A const expression. This should be a const, always a const expression. Oh, it's a free function, I remember. It's OStream, not OSstream. Yeah. I just called OSstream, it's actually OStream. We have a boilerplate. Okay, it must be a free function. Auto member operator takes a stream as its left operand. Oh, I know. Yeah, I know. So to handle IOStream, it's not like that. If you want to handle IOStream, okay. Hold on just a minute. I'm going to go prayer. Just a minute. I'll see you back. Alright guys, I'm back. And apparently there are some typos I made. Very funny. So okay, coming back here, let's go back with the bitwise operator, which is gonna be the OStream. Yeah, It's gonna be a standard O stream. Forgot that it's a standard O stream, and then do okay, I'm gonna make a reference to operator. Hello, operator. That do. I'm gonna take the standard O stream NOS, standard O stream OS, comma, string. It's gonna be a StrView SV. So I'm going to. Sorry, my dumb father is doing dumb stuff. So I'm going to os.write. Gonna be the stream right, will be the std. Whoop. Kenapa selalu ada itu? What? Why always that thing? Then do length or size? Oh yeah, this is for size. I like the length more, so I'm gonna use length. It doesn't make sense when I use size. Okay, it just doesn't make sense to use size. It makes sense to use length more than size. Unless it asks me to use the size of things, no. Then I'm gonna return OS. That way, this here, the main CPP here, I could have just I could have this, which will be okay, right? Oh, just don't quit. And then do G++. Oh, it works. Yes. I am such a saint in this. Perfect. It works. As expected, it works. Cool. Okay, that's cool. Yes, sir. I could do that. Now, could it also handle input? Or maybe I could use the standard FMT if I want to. But no. I'm gonna make this HPP8 declaration later, you know. I like this HPP site. It's great. There's no need for me to make it all different all of a sudden. I'm okay with this, you know. It's readable. It's human readable code. People love codes that are readables. Okay, so we have prints. And let's just call it just don't call it anything. And then we need iStream. Now, can I also handle input? I ask my friendly friend. Yes, you overload. I'm not saying some piece. Oh, I could handle inputs, but it's not recommended to make input. It's okay. Oh, yes. So I'm allowed to make output, but I'm allowed to make input, but it's not the right thing, since it's a, how do I say it? Since StrView is it's a read only, you know, it's not read and write. It's a read only data type. Okay, that makes sense. What about implementation? I'm gonna ask for the implementation for standard format in C++ 20. You need to specialize standard formatter for a StrView type. It's a bit more involved than operator. Yeah, okay. Yeah, it's okay. Oh, so if I use standard format, oh, this is cool. For from format spec support with fail align. This is actually very cool. Okay. Let's go implement for standard formatter, which is from the standard C++20. What am I saying, guys? My mouth is so watery, it's so watery and so ugly. Oh, include. Now technically, if I do this, the print, it also implements for print, right? STD print. If you guys don't know what STD print is, oh my god, you guys need to learn. That is the most powerful thing to have in C++, literally. So STD, oh wait, I just need to template this. Then, can I scroll down? Holy cow. STD formatter. Well, I make a structure out of it. So, struct STD formatter string view. STD formatter StrView. STD formatter standard string view, which is why I need to use string view, which is inside here. I guess I need to include string underscore view. Do I have string view? No, it's inside string. But wait, does string also include string view? Does string it also includes string view? I should call it header, not lib. Okay, it does not automatically do that. So, okay, and then I'm going to do. Okay, that's a structure, and then auto format StrView SV, standard string view and TX, whatever that is, I'm gonna follow this documentation here. I love documentations. Then I'm going to convert, so return standard formatter. I'm going to do standard string view format. Hey, what the hell? Alright, that's not. No, that's more like it. So standard. I'm going to use the string view sv.data. Oh yeah. String view sv.data sv.len, ctx. Oh no. I need to do this, by the way. And then do ctx. Is that it? Yeah, that's it. I think that's all it. And if I just do write, just to compile it. Oh. Dot class template. Ooh, what is this? Formatter. There's a problem with my code somehow. Oh, duh. I need to put something here. Oh wait, no. STD formatter. Error. Name qualified name does not name a class before that token. Struct. Expected that before. Sorry. using structure, right? So what's the problem? I have a template that. So what is the problem exactly? I don't understand. Inner parse. No, wait a minute. Something's not right. Let me just copy this, you know. Let me just yank this up. Just yank this up, you know. Let's just give it to. Because you're trying to specialize from mirror. Oh, do I have? I thought I have include standard format. You need to include format before the specialization. Oh, yes, I need to do G++. I don't know. So, standard C++ 20. Alright. Alright. I almost compiled. Yeah. Oh, I got it. By the way, sp.length doesn't exist. sp.length exists. Which is the one I use. The one I use is sp.length, people. Standard 22. Oh, okay. What is this? There is one candidate. Oh, I can't see. Did I write it? In file included from main.cpp format. No matching function for call std format StrView formats std string view and ctx const yet. In the included from type name blah blah blah. I cannot read any of this. Template argument is not derived from static basic format context out. Okay. Okay, what did I fail? I can't even read this code. This is the ugliest. This is why I call C++ is ugly. I hate C++, but I'm doing it. I'm still doing C++ code. I think it's because of std formatters. That is like, let me just yank these things up. Let me just yank it up. You know, yank them up. Let me just yank them up. Cool. Now this. Da 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 da. At the wrong time. Oh, I got the wrong type of CTX. Oh, oh, so CTX should be a format context. And it's a non-constant reference. Yeah, it's a non-constant reference. Yeah. Let me just check. I want to copy from you, Claude. You are divorced. It compiles. Although yes, the compilation time taking a little too long. So let's go. Let's actually see what we have here. Okay, instead of this is just dumb. We should also wait. Okay, does this automatically mean that I can print it out. Std print line. Please say yes that I can play out with this. Yes! Aha! Same city formatter, machinery under the hood. So I could do this instead. I'll just show you the real magic of C++, you know, the real magic of C++. We have something called print line, which is this. And let me just hashtag include print. And it's a standard 23. And I will just oh yeah, alright. So let's see. Feud string is that, and then do gonna be the length. Length. This will be as easy as something like, okay, this will be as easy as something like this. It's gonna be the sv.data, sv.length. Okay. If you don't believe me, this actually compiles. Very great. Oh, I mean, okay, sorry, I should use 23. It compiles, yes, and I just added a little. Why is there two? Why? What? Why is there two? That I have string. I have print SVO. Yeah, everything is great. So I have formatter, which means that it works now. I have a formatter. I have print line. I could few things now. I will ask Claude, can I make something, you know, a simple app, you know, using this? I'll make a little simple app to make this string view. Sure, you could. Ooh, we could do a text processes thing. Selective demonstration on string. Oh wait, I could make a simple cat program. Yeah, I could make a simple cat program. I think it's where's Soding GitHub? GitHub.com/ what's the Soding, Soding GitHub. I mean GitHub, sorry man. I know he has a GitHub page. I don't know, where is it? Where did he put it? Yeah. Oh, Rexim. Yeah, Rexim. Yeah, Rexim has things, GitHub.com/Rexim/ I forgot. What is that? I know. There is something called in his repositories. I think it's inside one of his repositories. I think I can find it. Let me just string view or string slice, I guess. Do I have string view? There's stb string. Let's check for string. Okay. Let me just check. Oh, actually no, I don't need that. I have my own. I think I have my own stuff. I could use, just clear this and city of false. Oh, sorry. Dot slash c dot slash c slash string view, and then envim cat dot c. All right, I have things here. So good. Lord, look at this. All right. What can I do here? I can do everything. Oh, there's a string split delimiter. Okay. Let me just ask this little guy here. Hold on, let me just pause this. I will think of what to build. Let me just pause this in a minute. Alright, I was about to make a cat program with it, but I'm just too lazy to do that. So let's not do that. So we have this string here. Let's have a standard Sahroni. Then we have standard, okay, we have Sahroni, and then we have Cinta Prabowo Ultra 67 Rabi Jakovic approved. Dot. We have this. Now we could do is do string view, and then let's go string view. Let's say, what do I call this? Yeah, SV, or yeah, let's call it SV, or no, just call it StrView. StrView is the best name. String view StrView. I want to do string view get the address of S. This is our we're gonna name this, you know, instead of S, let's go name it to Stir, because that's the best name I could think of. No meaningless name, people. Useful and meaningful names are the best. Okay, we can save that. Now let's go compile it. Let's go compile this stuff. Oh, but I thought this means that I will use. Oh, okay, no, no, I guess no. Yeah. Oh. Yeah, it have. Okay, cool. Now, what is to try? Maybe we could try to compare. Compare string view other. No, let's try with searching. You know, we could try searching. For example, string view substir. Ooh, we could substring that. You know, or just use find to find a C. Oh, that's to find a character. Starts with and ends with. There's so much thing I could do here. I could remove suffix. There is remove suffix. I've removed suffix. Why you scroll so far away, bro? What the hell? Remove prefix and remove suffix. So okay. What if I just take a suffix, then adding with a prefix? You know, I was just going to return a suffix, and I'm going to return a prefix. There's the StrView prefix and StrView suffix. I don't know. There's the end with and starts with and end with. Maybe we could have, you know, compare. What if I have compare? So compare StrView other const not accept standard size the min length standard. So compare m pointer other dot m pointer other dot mlen. The R results to 0 or 1, right? Okay. So let's compare. Let's have some string view, or let's make some string view. StrView 2 is gonna be StrView 1. It's gonna be Sahroni. God damn it. Benci Prabowo Ultra 69 Rabi Jakovic disapproved. And then we could have something like int compared will be the we're going to compare two strings, right? So to just do string view, I mean. So which one do I use? I'm gonna use a string view 1 dot compare compare, and then do string view 2. I'm copying, you know, I'm not referencing stuff altogether. Then I will just do print line, standard print line compared view. I'll do that and just do compared. Let's see if this works or not. Let me just do I. Hey, that took long to compile. That took long to compile. Oh my god, what the hell? That's so strange. Compare view 1. Oh, it returns 1. Why do you return 1? Let's just check. Oh, because there's one difference. Or two difference. Let me just check. Why do you return 1? You return 1 because m len is greater than other len. Really? 1, 2, 3, 4, 5, 6, 7, 8. Oh. Yes. 1, 2, 3, 4, 5, 6, 7, 8. So how is it m len greater than this? Let me just check. 1, 2, 3, 4, 5, 6. Oh, I'll just prove. Just print line. Just do StrV 1 length will be that, comma, let me just say the StrV 1 dot length, and start print line StrV 2 length that StrV 1 dot length, I mean StrV 2 dot length. If I do this, do that, do this, okay, and then do main. Oh, okay. Holy cow. How is your mlen? How do you return 1? Actually, how do you return 1? There is a logic. Something is not right. How do you return 1 when your length should be... there's this bug here. What the hell? I didn't use StrV 2. If I use if I use StrV 2, there's a bug there somehow. I don't know what does that. That's funny. Oh my god, that took... How? How? What? What is the logic behind this? Sorry. What is the logic behind this? If the color's length should be mlen, The other length should be this length. Whoa, whoa, what the fuck? Okay, okay. You know what? Fuck it, I'm flipping it, dude. I'm flipping it. Okay, I'm flipping it. I don't understand. How could that happen? Why? How? Oh, okay. Maybe because it actually works that way. I just don't know. I don't know. Maybe. What the fuck? What the fuck? Maybe I did something wrong in the past. I don't know. What the fuck? Huh? 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 I'm using StrView 2. StrView 1 is the other, so what the fuck is happening? Alright, okay. Okay. Yeah, well. That's dumb. Am I going to end it here? Probably I am. This is some kind of machinery, you know, in compare. Yeah. This is some kind of machinery, I think. It works with standard print line. It works with standard print line. StrView 1. Let me just do this and oh come on. Oh come on. This will be that. Just gonna get T there. T. Oh, okay. Then I will do StrView1 dot data, comma StrView2 dot data. I genuinely don't understand how that happens. Maybe if I flip things around, maybe if I do this instead. So maybe if I do order dot m underscore len, and it should be mlen, which is the same thing as I'm doing it for. I'm just flipping this, you know. I don't know, man. Order dot mlen. I don't know. Let me just check. Oh, okay. Sorry, what? Huh? Print line is a member of STD. Did I not print? Did I not? What the fuck, man? Hello? Are you okay? Print line is not a member of STD. How are you a member of STD? Huh? Huh? What the fuck? I have included print, which means it's why am I using 23, man? What the hell? I was from 23. Now how is it 22? Yeah, I have that now. Cool. This has more length. Okay, it's -1. Makes sense. If it's -1, okay, then it'll be -1. This should make sense now. This should do it now. If it does not do it, I'm so fucked, bro. Yes, this is much better than that. All right. By the way, using this is a little bit dumb. Let's just not use that. Let's just put some random space between you two. Like a child, they call me a child. Oh yeah, that took like a long, what the fuck. Yeah, well, we have it now. Cool, okay, cool. We have string view in why do I still have it -1? I don't understand it. Oh my god. What the fuck is the logic behind this, dude? Huh? What the fuck is the logic behind it? You know what? Let me just. Yeah, I'm okay with this, man. I'm okay with this. If you're that serious about it, you're sorry. If you're that gay about it, yeah, it's all yours. Also, let me just check what features can I use more. All right, what features can I use more? Can I use something like? I have removed prefix. Oh yeah, let me just remove prefix. You know, let me just remove some prefix. Let's go remove prefix. How do I remove prefix? Yeah, I know. Let me just remove this. Let me just do StrView1 dot remove prefix. What is it, prefix or suffix? Let's check. How do I use remove prefix actually in like standard? Remove prefix. StrView. Let me just check. How do I actually use it? Ah. Okay. I get it. I get how it works. By the way, I want to close you. I want to close this, close that, close this, close that. Okay, so I don't want to do. Okay. Yeah. So instead of that, I'm doing that. Let me just do this. So if standard string v dot starts with, let's have a prefix. Let's go make our prefix by the way, it's StrView1. Let's say Cinta Prabowo. You know that. And then will this actually work though? I don't know. If I did that, I want to do StrView1 dot remove prefix. I'm going to the this. Oh yeah, this should be yes. Start with should be some kind of length. Do I have length? For that, I'll just get start with. Where starts with? So starts with uses StrView prefix. It catches the prefix of that. I could just pass this, you know. Let's just we have length, you know, strlen. You see string, I guess. Is it C string? Yeah, it's using C string. So I'll just use hashtag include C string. Just to put strlen here, which will work with that. Cinta Prabowo. No, well, I I'm guessing it doesn't work this way. This also will be a 2-hour long video. I just noticed it. Yank it. And this will be 2. B benci. This also will be 2. Oh, come on, where are you, man? This will be benci. And okay, that's done. Probably this one work. I bet I bet this doesn't work. Oh, I mean, it's still there. Oh, because it doesn't start with that. If I want to start with, I should remove them. How do I actually do them? You know, I should probably just use something like, you know, Saharoni Cinta. Yeah, Saharoni Cinta, and this will be Saharoni Benci. Saharoni Benci. So we'll just remove this to be Saharoni Benci. Let me just do that. Let me just boom. We have that. Ah, so nice, so nice, so nice, so nice, so nice. So we've just removed Saharoni Cinta and Saharoni Benci from the game. Alright, cool. That's cool. Yeah, I'm approving this. This is a really good project to work with. If you guys want to learn more about C++, doing some STL, rewriting some STL methods your own, I think is a good way. Let me just. So yeah, as I did here. Oh wait, I think my CPU usage is getting higher. Why is my OBS Studio? Let me just wait. It still hits on 60 FPS though. Cool. So okay, what I did here is that I have just rewritten the standard string view from the STL, C++ STL. It was first implemented in the C++ 17, and I think this is a nice way to practice your C++ skill. Although yes, some quirks happen. This is a proof that C++ is a really high-level programming language. That it's actually not your C replacement, your current C replacement. But it's nice if you want to work with C++. I think rewriting some STL utilities is a great approach. You will know how low level they work. You will know how high level they also work. So first you know how they work in the low level side, then you know how to use them in the high level side. That's a really good thing to do, and I think that will be everything. My CPU is frying so badly. Thank you for watching, and I see you guys.